All right, hey everyone. So let's go to get started since it's 6:10 p.m. There we go. Okay, so just starting with some announcements. We will be having our quarterly Cyber Cross ICPC Sautel Run Social. This will be happening on Friday, May 9th. So this is in 2 weeks. We will be meeting at the Bruin Bear statue roughly at 6 p.m. If you do have like a class that goes until 6 p.m., like I think like 1:32 or some discussions do, don't worry, we'll wait for you. We will then split into two groups, one of which will run there and the other which will take a bus there. The bus leaves from like in the medical complex. You'll have to walk a little bit, but you won't have to run. And yeah, you can bus there. You can run there, bus back. You can run there and back. You can bus both times. It's up to you. Though if you do plan on busing at all, just make sure to bring your tap card with your UCLA Transit Pass enabled. Another thing, the CS Town Hall has been scheduled for spring 2025, Thursday, May 15th at 6 p.m. This is a great opportunity for you to give feedback to the CS department by first, number one, filling out their feedback form. I've linked it here. You can also find it in the Discord event for this. Just like answer as many questions as you'd like. Say, what classes you've enjoyed, what classes you want changed. Is the CS department listening to your feedback? Are there things you want to tell them, et cetera, et cetera. And then we also have the actual town hall itself, where you can show up and give like live feedback to the professors and the department who will show up and just do like a live Q&A session, as well as some updates. I don't know how much y'all are aware, but the requirements for the CS major specifically are planning to be changed for next year. It won't affect you if you're currently in the CS major, but you will be given the option to change to the new requirements. So there might be some interesting announcements given at this upcoming town hall. Just saying. And if you do want it, food is provided, so go ahead and RSVP. Another thing, this is just a side note, Lockheed Martin, which is one of the sponsors of ACM Cyber, is holding a Discover Lockheed Martin event this Wednesday at 4 p.m. I realize I did not put the time. If you do want to go to that, it's just a Zoom online 1-hour talk. Get to learn more about Lockheed Martin. I think they have someone talking about like system design. I'm not too sure. But yeah, if you are interested, fill out that RSVP like ASAP because they will be sending out the link tomorrow. And yeah, if you could show your support for our sponsors, that'd be great. I'm legally obligated to say that. Anyway, more announcements. PBR will be playing BioCTF this Saturday. Go ahead and meet at the Denev Turner at 11 a.m. and we'll go out for dinner. Again, as for all PBR meets, no prior experience is required. On Wednesday, we will be having a talk from Eddie, right. I don't know why I blanked. On quantum cryptography this Wednesday in Kinsey 1240 at 6 p.m. if you're interested in showing up and learning a little bit more about quantum cryptography. And then lastly, our weekly cyber basketball socials, Friday, 6 to 8 p.m. in Hitch Courts. Cool. Any questions? I don't know why there would be. So let's give it up to Ronak, who will be talking about protocol level web attacks, or just in general.
Yeah, web attacks.
Web attacks.
Yeah.
Okay.
All right. Hi, I'm Ronak, and I guess talk's gonna be about protocol level attacks. So the term protocol level attacks, what the hell does that mean? I know what a protocol is, a level is, and an attack. But like, what is a protocol level attack?
It's a PLA.
PLA. Exactly, yeah. So I guess like you'll find the answer to that at the end of this talk, but just stick with me for now. Wait, how do I do now? Okay, so before we talk about the protocol level attacks, so let's give some background in web security. So in web security, there's this attack called the SQL injection. What this is that some code might have some SQL query, and inside of this query, like the application code itself is just using string concatenation to build a query from trusted stuff and untrusted input like username. And the gist of this attack is that if we have a code that looks sort of like this, we can set the username to just have like quotation mark or 1=1 in it, and then that'll like escape out this quote and just be true for everything. And then this query would match every single record. So this is this thing called SQL injection. And I guess like for injection, like the mitigation to this whole thing is to just like write better code. So like the whole burden of like preventing this, it falls on the application developer and Like the developer can just write good code, use a prepared statement. And the thing about this is that while this was like a very prevalent issue in the past, like think like 2010, like this was a massive issue. Nowadays, developers mostly know about this, so this specific issue is much less prevalent. Like, I was in CS 143 last quarter, and Ryan Rosario was like talking about this. So when this stuff has like made it into a UCLA course, like this stuff is not happening anymore. So now that we know that now that SQL injections are sort of they aren't just as like prevalent as they were, like you can't just type in or 1 = 1 into every single website and auto-pwn it. Like we have to like try to find some new attack vectors to I guess like hack web applications. So the thing about these database queries is that the way that most developers see database queries is sort of as this like magic stuff over here. Like your server just tells the database, give me the users, and the database like just gives you the users. But the thing is that like this is just magic to us, right? But the real world doesn't have magic. There has to be something that actually like sends over the query from the server to the database and the result back from the database to the server. So this thing is the protocol. And this presents like a new opportunity. What if instead of attacking the whole application, like the whole tower over there that's pretty secure, what if instead of attacking that, we attack like the protocol, which is the bridge between the application and the database? Because this protocol, it's just some library like made by some guy. It just exists, right? So what if we just attack this? If we attack this, we could essentially do the exact same thing as an SQL injection. So I guess to demonstrate this, let's look at this this database called Memcache. So Memcache is just this software. It's kind of like a database. It basically just does two things. You can set a key value pair and you can get a key value pair. It's basically just a dictionary. And the Python interface for this using the ilibmc library, it's literally like a dictionary, like it's the same syntax and all. So the thing about this is that from the developer's point of view, like this is sort of magic. Like this is just like a magic dictionary in which I can just set strings and I can set string key value pairs and I can get string key value pairs. And with a dictionary, right? If you're in Python and you're using a dictionary of strings, like there's no real restriction on what strings you can put into this, right? Because let's say like Python said, hey, no semicolons in your strings or dictionaries. That'd be pretty stupid because I might want semicolons in my strings. So and the thing is that from first glances, this thing does it should allow this because I mean we're using normal APIs and not string concatenation. So how on earth would we ever attack an application using pilibmc? Oh, it's there?
Yes,
Oh,
it's fine.
it's okay. I need to walk around. All right, so to attack this, we can look at the protocol that's actually powering Memcache. So under the hood, Memcache isn't just some magic dictionary. Memcache, it operates by having a Memcache server, and then you send messages over to the server. Like you just send text messages over to the server, and then to have it do its operation. So just as an example, this is sort of what a Memcache protocol looks like. For setting a key value, you type in set, then your key, some flags over here, and then you type in your value followed by a carriage return. And then for get, it's pretty simple. You just type in get and then the key name itself, and then a carriage return. So carriage return is sort of like how you delimit a command. It's kind of like a semicolon in other languages. But yeah, this is the Memcache protocol. It's pretty simple. The thing about this Memcache protocol is because it's just a very simple text-based protocol, there are a few things we can try to do to this. So notice how all these get operations, they just put the key into the text over there. So if we're just putting the key into the text of the message, what if we just started injecting stuff into the message? because like I mean the key is just there, and the key supports like any character. So like what if we just put whatever characters we want in there? And there's nothing really restricting us from doing so. So the thing is that if we put in this malicious payload over here, if we put like if we add /r/n and then we call it and we add like a set command in here, the thing is that what this is going to turn into when we use the get protocol is that it's going to expand to get some key, and then it's going to type in that carriage return and then our malicious command that we've snuck into here. So all of a sudden, like even though this like even though our application was secure because you should be able to put in whatever string you want, even though our application is secure, because our protocol is pretty dumb, we're able to just like smuggle in any like queries that we want into here, and we can just like modify the database however we want. And this is a pretty like useful attack. And I guess just a side note, so like it may look like, we're just setting like a key value pair in the database. But the thing is that like due to some other issues with memcache, memcache is using this thing called pickle to serialize its values. And I guess if you were here 2 years ago, you would have seen my talk on pickle and how deserializing pickles means that you can execute whatever code you want. So like we're not just setting key value pairs, like this gives us the ability to execute whatever code we want on the server. So this is like a full pwn, like the ultimate exploit. And yeah, so I guess so that sounds pretty serious what I told you about, right? So the thing is that I'm unfortunately like not the person who discovered this. The person who discovered this a while ago. But like in 2022, someone opened a GitHub repo, a GitHub issue on the repo saying, I think this is like a vulnerability. Can you guys solve anything? Like, I guess responsible disclosure doesn't exist, but whatever. Like, they're like, hey, this is a vulnerability. Can you please, because this like can cause RCE and this is like really bad. Uh, and then the author response of the library was to quote, hi, this can be secured through enabling the verify keys option. So like you have to according to the author, like you have to like enable like additional options to make this library secure, which is like stop bringing meaningless opinions like security is a joke. Right? Yeah, so yeah, I guess TLDR, do not use pylibmc because the author is like kind of a clown. But yeah. So that was for text-based protocols, right? But the thing about text-based protocols is like they're like always inherent, like they're always inherently vulnerable to these sorts of injections. Like HTTP is vulnerable to the same like CRLF injection. And just like text-based and like SQL queries themselves, right? Like these are text queries. And just like whenever you have like English text and you're parsing that, like you can always like just try to introduce some parsing discrepancies to like do your own shenanigans. So what if like some nerds in this club might be saying text-based protocols are kind of dumb. Like why not just use binary protocols because you don't have to parse anything and also like it just works. Yeah.
Wait, Ronak, text-based protocols are really dumb. Like, why do they exist?
Exactly. I think this is not just one person. This is many people, and one of those people is me. But yeah. So the thing about binary protocols is that like binary protocols themselves also have shenanigans done to them. So as an example, let's look at PostgreSQL. If you don't know what PostgreSQL is, it's just like an SQL server. This is used by many big name companies. This is like probably one of the most widely used SQL databases in existence.
Also used by ACM Cyber to power all of our infra.
Yeah, we're the biggest company. Okay, so the way the PostgreSQL protocol works is that the client sends these packets over to the database server to process. And the rough format of these messages is like this is not the complete format. This is just one of them. But the way it works is that like you have some sort of like opcode over there, like a message type. Say in this case, the message type is saying that this is a query packet. And then after that, you have a length field. And this length field is like it, so this is like the length of the value, like the length of the payload you're trying to send. So in this case, like this is the length of the query that we're trying to send. And then after that, we have the value. So this is like a pretty standard like sort of design. It's like you first encode the length, and then after the length you encode the value. This is pretty standard. I think like most databases use this. Like MongoDB uses this in some way as well. And yeah, so this is a pretty simple protocol. This is a binary protocol. I love binary protocols. All right. The thing about this protocol is, like, notice how this thing over here, it's 4 bytes. And the thing about 4 bytes is that, like, well, it's 4 bytes, right? Like, it can only represent numbers up to 2 to the 31 minus 1. Like 2 to the 32 minus 1, right? So, like, what if we just sent a payload so massive it just overflowed this thing, right? So this is like an attack that we can actually do against PostgreSQL. And if we just send a payload, like, you know, just like 4 gigabytes payload, like it'll overflow the length field, and then this will set the length field to be 4, which will then result in like in the binary thing being parsed as like as this being one message, and then the rest of our query being another message. So this will also allow us to like smuggle in additional like queries. And yeah, I guess like this is just like a short overview of the binary protocols because like as you might imagine, like sending over 4 gigabytes of data for every single attempt you have is kind of like gonna like kill the server, because you know I think the creators of this attack said that like you might need to send over like 20 to 30 gigabytes of data, and if you do it like the naive way, which you know 20 to 30 gigabytes of data is a lot of data, and you're probably gonna end up like taking down the server or something. So I guess if you want to like learn more about this specific attack, there's a very good talk by Sonar Source. Sonar Source is the team that figured this stuff out, and they're a really well-known security group. So go check out the talk if you want to learn more about how to make this specific attack practical, because it's kind of like a rabbit hole. But yeah, I guess just like the summary of these protocol layer attacks is that text-based protocols can just have like injections in them, which are like a lower level than application logic. So even if your application logic is perfectly fine, like due to the text-based protocol itself being something very weak, you can still have vulnerabilities and you can still attack these. And also, binary protocols are not immune. Like a misconception that a lot of people have is that binary protocols will sort of protect us against all of these like random like parsing things, but binary protocols can also have random issues like CS33 type issues, like the like having a weird message length. And I guess the key takeaways for this is that like whenever you're developing something, you should always like try to understand how like what the software is doing under the hood. Like if you understand how like that MySQL is using like a binary protocol, you might try to do stuff like restrict the payload length, uh, and yeah, just other stuff. And also like in addition to understanding how the protocol works, you should also be trying to like do security proactively instead of reactively. So instead of like reactively saying like, oh no, there's a vulnerability in memcached or something, instead of saying, "Oh no, there's a vulnerability, I have to patch it," one thing that we should be doing as software developers and security engineers is to like restrict the character set and also set size limits, because like just like two simple things like they make attacks like a lot harder, and like these two things negate all of those previous attacks. So yeah, just thank you for this.
All right. Anyone have any questions for Rona? No, all right, cool. Thank you, Ronak, for that really cool talk. All right, other hand to pause. All right, so starting this week, since the labs have started settled, we will be taking lab attendance. So for this week, if you could scan this QR code, it is the same link as previous quarters if you've done it before. The code word is protocols, if you could fill that out. So everyone in a lab should be filling this out. This is how we know that y'all have attended.